Hi, in this video, I would like to make a sharing on a topic of analog value processing, specifically for SIMATIC S7 CPU type S7-300 PLC. So in general, when we talk about analog value processing, it can be either inputs, analog input, or analog output. So analog input is related to measurement. So we can measure, for analog input, we can measure things like liquid level, for example. Temperature, liquid or gas flow, so it is flow, pressure, it's a certain vessel. We can also measure things like velocity, speed of motor speed, and etc. etc. This is the analog input. On the other hand, we can also have analog output, whereby analog output can be things like the opening percentage of opening, percentage of valve regulation, or percentage of, I think this should be percentage of regulated valve opening or closing. And we can also have a percentage of motor speed, for example, percentage of motor speed, or even percentage of heating element. Okay, so in this particular illustration, I've prepared an open tank, whereby this open tank we need to observe, or we need to monitor the level of the tank. So in terms of level, it can be, we can monitor, for example, the level in between. Okay, the level in between. So in general, we can have 0%, mean this one is empty. We can have 100%, this is full. We can also have the values in between. Okay, the values in between, it can be 72%, 50%, 23%, so on and so forth. So we should have values in between. In general, the measurement of an analog value, we can observe it in terms of electrical signal, whereby it can be in terms of current in milliampere, or in terms of voltage. So the popular signal for current can range between 0 to 20 milliamp. Okay, in industry, the most popular signal type is 4 to 20 milliamp. Okay, in terms of voltage, we can have range. There are quite many range. One of the most popular range is 0 to 10 volt. So we're going to look how can we program a ladder diagram, how can we connect this particular measurement and program in terms of ladder diagram to using SIMATIC S7 software, particularly for S7-300 PLC. So in general, for S7-300 PLC, in terms of measurement, or in terms of monitoring, we can use scale instruction, which is in a function that we call as FC105 scale instruction. It looks like this. Okay, it's look like just an ordinary instruction whereby it has enable input, enable output. This one here should be FC105 scale instruction. It's basically scaling the values. Then we have input, then we have the high limit, then we have the low limit, then we have bipolar. Okay, in terms of output, we have return values, and out. Okay, recall that for analog input, the values is basically real values. It can be a floating number. So when we talk about floating number in terms of data type should be analog input, data type is word. So looking back at the illustration, we can say that our level transmitter is going to provide us electrical signal, whereby that particular electrical signal is connected to analog input card, which has a word address. Okay, so in terms of addressing, we can assign the address depending on the card. Let's assume that the address is IW256, for example, IW256, which means this particular level transmitter is connected to input address data type word, which address is 256. Okay, so we can write here the address for input is IW256. Okay, IW256. So the limit for the tank, we can say that the high limit, we can say it as 100%. So the high limit is 100%. So we call it is 100.0. Low limit is 0%. So we can write it here as 0.0. And we have to make sure that this particular terminal bipolar, for this time, we have to make sure it is giving us status 0. Should be status is equal to 0. So we can assign a contact with a certain address of bit. So let's say this one is M0.0, whereby M0.0 should be 0. Okay, in terms of output, we can assign a memory type of output. Let's say we're going to use output address 20, but because of here we have word data type, and here we should have double word data type. Let's say I'm going to use address 20. Return value, we have to use word data type, so I'm going to use memory word 10. Okay, so in terms of ladder diagram, it's going to look more or less like this. Okay, it's more or less like this. Okay, so this is a scaling the input. So this particular ladder diagram, it scale the value of input word 256, which is actually the level transmitter to monitor the tank level, and it will provide the values. It will internally convert the values, the decimal values of the observation of these particular sensors, and convert the values between 0 to 100%. And then now I'm going to explain why it is the bipolar should be 0 in terms of the conversion. In terms of the conversion, so internally the values will convert between 0 to 100%. So it will convert the value between 0.0 to 100.0, and then the minimum value 0 will correspond to 0, and the maximum value for which is 100.0 will correspond to 27,648. Okay, this is the unit representation for the maximum number of conversion for this particular scale instruction. So we have values in between for the real values in between, and we also have the real values in between. So 27,648 is correspond to the sensor value. So the values in between is basically the real values from sensor, and it will convert between these values for this particular output. Okay, for example, we can have values for values such as maybe we can have values in between here. For example, we have 13824 can correspond to 50.0. So when this particular sensor read the level of about 50%, so the level 50% is actually correspond to 13,824, and when this read 13,824, the output, which is this output, will actually provide us output of 50.0, which indicate that the tank is 50%. Okay, I'm going to show you, I'm going to provide to you the simulation using a PLC sim. So we're going to look how can we adjust the programming using a SIMATIC STEP7. I think before we go on the simulation example, I'm going to explain to you more about this one. So it's actually the conversion, and because I'm going to relate this particular conversion with the signal, whereby we can have a signal such as voltage or even current. So let's say we have a tank, for example. We have a tank again, we're going to use the same tank, which is actually this tank, and this particular tank can provide us the measurement signal in terms of current and voltage. Okay, so we know that the graph that we're going to do the conversion, something like this. Okay, whereby the maximum is correspond to 27,648, the minimum is 0, and the maximum, the physical quantities can be 100.0 or even 0.0, which is actually this particular units is correspond to can be, if we say it is current, so this one is 4 milliamp, this one is 20 milliamp. So if it is voltage, so it can be 0 volt, so this can be 10 volt. Okay, so we can somehow tabulate, or if we want to get an expression about the conversion, so we can somehow create a table to tabulate certain values. For example, okay, let's say we have current, we have voltage, and then we have the what we call it as the units. Okay, so let's say I'm going to show you maybe if the current is 4 milliamp, of course the unit is 0. Okay, if we have current of 20 milliamp, the unit is 27,648. Let's say I'm going to choose maybe another four units, I mean four current in between. So let's say we have let's say we have 16 milliamp, then we can have, for example, 10 milliamp, we can have 10, maybe here we have 7 milliamp. Okay, so we can do a simple mathematical calculation. So we need to find what is the value here. We can say that for Okay, I'm going to demonstrate using PLC sim. So I've created a project. So I name as a project as the analog tank level 2. So next I'm going to copy the library. So I'm going to open the library. So open project, this is library, go to standard library. Then I'm going to copy FC105 into my project block. So this one is my block. I'm going to copy FC105, just drag and drop. So we have FC105 inside my project. Okay, so I open OB1 and then oops, I already have this one, so I'm going to delete this. So I'm going to put the FC105 here, which is located in library, standard library, under TI S7 converting block. So I'm going to get FC105 scale convert. Then I just put yes. Okay, just put yes. Okay. So look at this one. This is enable terminal. This is enable out. In terms of input, as I mentioned earlier, it should be in terms of input word 256. And the high limit can be 100%, so 100.0. The low limit is 0%, so it will be 0.0. So this one is to make it unipolar. So we have to make it we have to use bit address, which then to make sure that this one is 0, to make sure it is in unipolar configuration. Written values, I would like to use the let's say just a memory word address, let's say MW10 for example. The output can be a double word address, so I will just use the memory double word. And just use memory double word randomly. I'm use memory double word 20. Okay, so then I save it. I can download from here, but I just want to download from this one. So just to make sure that I download the OB1 as well as the library of FC105. So just highlight both of the function, OB1 and FC105, and just press download. Okay, I guess it is completely download. Just to make sure, just put it download again. Okay. So in terms of simulation, I have to use the memory word address here because when I use I address, it have to be a physical input. It have to be a physical transmitter. So just for the sake of simulation, I just change it to MW. Okay, for the sake of simulation. Again, I download it. Okay, then I put it the monitor on the monitor. So let me turn on the simulation. So I think there's something wrong with the simulation. Okay, now it's working. Okay, so if you look at our the tabulation, so for example, we can just change this one to for example 27,648. So when 27,648, which is correspond to the maximum value, the output will be 100%. So if the sensor measures 27,648, it is 100%. Now if we can modify it to, for example, 5184, it corresponds to 18.75%. Okay, this is the tank level. And just gain another value, maybe 10,368, and we expecting it going to show us 37.5%. So 37.5% here, and we have to change maybe last one, 20,736. So it's going to show us the tank level now is 75%. So we have 75%. Okay. Okay, I hope this explanation sufficient for you to learn about the scaling values for analog input. Thank you.